Hey guys, welcome to my channel, The Tech Coders, and today we are going to solve question number 1872C, that is non-Coprime splits of Codeforces. Okay, this was the part of Codeforces round 895 and division 3. Okay, so let's understand what question is stating to us. Question states that you are given two integers L and R where L is less than or equals to R, and you need to find positive integers A and B such that the following conditions are simultaneously satisfied. The first one is that the sum of A and B should be greater than or equal to R or less than or equal to R. Okay, and the second condition is that GCD of A and B, that is highest common factor of A and B, should not be equal to 1. And if in case we are getting C as 1, at that time we are supposed to return -1. That's it. This is our question. This is simple question. Let's discuss further. See, over here are the test cases. So we can see that in some cases the value of L and R is unequal, and in some cases the value of L and R is same. So we'll discuss for both of the cases. Let's go. So see, after analyzing all the test cases, we may say that in some cases L will be equal to R, and in some cases L will not be equal to R. So over here we'll consider when L is not equals to R. Okay, and what were the two given conditions? The first one was L is less than or equal to A plus B, and it is less than or equal to R. And the second condition was greatest common divisor or highest common factor of A and B should not be equal to 1. Okay, so now see, in some cases R will be even, and in some cases R will be odd. Okay, let's take example of an even number, that is 8 and 18. So see, we know that every even number is divisible by 2. Okay, what I said, every even number is divisible by 2. So let's take A is equals to 2. As every number is divisible by 2, I'm gonna say that I'll take one number as 2 and the second number will be, let's find what will be the second number. I'm saying that over here R is equals to A plus B. As I take A is equals to 2, what will be the value of B? B will be equal to R minus 2. Okay, so over here what is R? R is 8. So what will the value? 6. Again over here, as it is an even number, I'll take one number as 2 and the second number will be 18 minus 2, that is 16. And now see, both of these examples are satisfying this condition, and both of these examples are again satisfying this conditions, because see, the GCD in both the cases is 2. What is it that? GCD in both the cases is 2. So now we are done with the even part. Let's move to the odd part. See, the example of odd numbers are, let us suppose we are having 7 and we are having 15. So for odd number, we do not have any number which can exactly divide an odd number. Okay, for the sake of even number we were having 2, but for the case of odd numbers we are not having any such numbers. So what we can do is that rather than taking the exact number, we'll do one number prior to this number, that is 6. We'll take one number prior to this number, that is 14. So what I can see that now this number is even, now this number is even. Okay, what we are done, we have done R minus 1. So we know that when we divide any even number by 2, it is exactly divisible. So what I'll do, I'll take 2, then what we were doing over here, we were doing this R minus 2, that is 6 minus 2 again is 4. As it was 14 over here, what will the combination? 2 and 12. Now see, both of these combinations are satisfying this condition, and both of these combinations are also satisfying this condition, as GCD over here is 2. So let's conclude over here. Whenever we were having any odd number, what we were doing, we were taking A as 2 and we were taking R minus 2. What is R over here? See, initially it was 15, but what we did at the first place, we did R minus 1. So it will modified as R minus 1 minus 2. So I can say that my final combination will be 2 minus R minus 3. That is, for every case of odd numbers, my combination will be this. Let's take another example. Let us suppose that we are having 19 as a number. Okay, so what will be the combination according to this outcome? That is 2 and 16. And see, yeah, this is satisfying this condition, and this is also satisfying this condition, because see, the greatest value of L when L is not is equals to R can be 18. Okay, can be 18, and 2 plus 16 is 18. So we are not violating either of the conditions. So yeah, we are done with the case when L is not is equals to R for both even and the odd part. Okay, now let's move to the case when L is equals to R. So guys, see, now we'll discuss for L is equals to R. Okay, let's say that even here also we'll have a two condition, that is even and odd. So we have already derived a formula for even, that is whenever we have an even number, our combination will be 2 and R minus 2. Let's take an example. For example, for L over here is 16. Okay, so what will be the combination? 2 and 14. Let's check the first condition. 16 should be less than or equal to 2 plus 14, be less than or equal to 16. Yes, this is satisfying the condition, and GCD of this case is 2. So yeah, we are right. Okay, now let's move to the odd case. This is a tricky part which we are supposed to understand. Let us suppose that we are having a number as 15. Okay, when we are having an odd number and when L is equals to R, at that time we'll try to find one of its common factor. That is one of its common factor. Let it be 3, let it be 5. Okay, and after finding this common factor, what we can do is that, let us suppose this common factor is equals to x. So what will be our combination? X and R minus x. See, it was 3, comma 12. 15 minus 3 is 12. For this sake, 5 and 15 minus 5 is 10. Now see, this is satisfying the first condition. How? Let's see. 15 less than or equal to 3 plus 12 is less than or equal to 15. 15, 15, 15. This condition is true. And for this case, what is the greatest common divisor over here? It is 3. And for this case, again, what is greatest common divisor? That is 15. So yeah, our solution is right. We are not wrong over here. So what we can say, when L is equals to R and odd, we'll try to find a common factor, and let us say that common factor is x. So what will be our combination? Our combination will be x and R minus x. Yeah, we are done for this case also. But see, now comes a tricky part. There will be a situation when a number won't have any factor. The number won't have any factor. That is 7. And that number will be a prime number. So I can say that the case when I couldn't been able to find any factor, at that time I'll simply output -1. That's it. Because at that case, the GCD will always be equal to 1. See, let us take an example of 7 only. What are the possible combinations? 1, 6, okay, 2, 5, and 3, 4. In all these three cases, the GCD is 1 over here. That's why we'll simply output -1. Okay. Now, so now what we have discussed, we have already derived a formula for even part. Done. For odd part, we say that we'll try to find one of its factor, and after finding that factor, let us say the factor is x. What will be the combination? X and R minus x. And in case when we couldn't been able to find any factor of that particular number, then that number is prime, and hence we'll simply return or see out -1. That's it. See, this is our last case and the edge case. Okay, this is very important. So try to understand. Let us suppose that the value of R is equals to 3. Okay, and L is equals to 1. So what can be the possible combinations? It can be 1, 1 or 2, 1. Okay, again, if it is equals to L is equals to 2 and R is equals to 3, what will the combination? Either 1, 1 or 1, 2. So we can see over here is that, see, we are satisfying the first condition. But when it comes to GCD part, GCD in all these 4 combinations is 1. GCD in all these 4 combinations is 1. And let for any value of L, let's take R is equals to 4. What I said, whenever a number will be even, I'll do a simple one thing. I'll take A as 2 and the second number will be R minus 2, that is 2. See, this is satisfying the first condition. At the same time, this is also satisfying the second condition, as the GCD over here is 2. Okay, so we can conclude that whenever the value of R is less than or equal to 2, at that time we'll simply out -1. That's it. Okay, this is because our edge case. At that time we couldn't been able to find any combination such that their GCD is greater than 1. Okay, so yeah, we are done with this. Let's understand coding part. So guys, let's understand the coding part. Okay, this is our base case. That is when R is less than or equal to 3, we were simply printing out -1. And when L was not is equals to R, so in case of even number, we were taking A as 2 and B as R minus 2. And when it was odd, we were taking A as 2 and B as R minus 3. Okay, we are done with this. So else, when L is equals to R, at that time, if it's an even number, by mistake I wrote N over here, it was R. Okay, whenever the value is even, we were taking A as 2 and B as R minus 2. And this is for the odd case. We are iterating from I is equals to 3 to I square root n, and we are trying to find a factor. If there any factor exists I, then the A is equals to I and B is equals to R minus I. And in case there is not any factor, that means it's a prime number. We were simply printing out -1. That's it. Okay, so I hope you understood all these concepts and explanation very well. Please like this video, subscribe our channel, and share this with your friends. Okay, and in case if you're having any doubt in particular question, then drop the link of that question or question name with question number in the comment. We'll definitely discuss it afterwards. Okay, so thanks for watching guys. Have a good day ahead.